there are certain guidelines we all need to pay attention to. First of all, I'm going to share you the project link. As I'll share, I'm going to put the timer on from my side. And whatever time we'll have, let's say if we have 45 minutes to do that project statement, you people will have to submit it right after 45 minutes, because once I stop the timer from my side, all the assessments submitted afterwards are not going to be taken up for assessments, right? So we all have to submit it before the time elapses, right? Now, second thing is, I am going to tell you people the project statement. We will have a quick discussion over the problem description to give you a heads up. But once I share the project link, I am not entitled to provide any sort of help throughout the next 45 minutes to you people, right? So please do not come and ask, ma'am, I'm stuck on this. This is not happening. How can I do this? No, this is something you people will have to do it without any help from my end, right? So those 45 minutes, you are not going to get any sort of help from my side. Third, very important part is, please do not open any other tab or the browser window, because your screens will be monitored. And if in case we found any sort of other activity being happen, this project is not going to be considered for your assessment then. Right now with that, I'm going to start with the project statement over here. What we are going to do is, I'll be sharing this link once I explain this part, because accordingly we'll start the timer then, right? So first of all, let's understand what is the project statement and what you people need to do. Now guys, you have to create multiple functions today in order to get the desired output. Ma'am, what's the desired output? That you have to check if a number plate is miraculous or non-miraculous. Now, which number plate we will call it as a miraculous? These are the conditions for number being miraculous. What are they? First condition is that the number has to be a 4-digit number. Second, sum of 4-digit number has to be a prime, right? So first condition is that the number has to be 4-digit number. If the number is 4-digit number, then we have the second condition, that the sum of these 4-digit numbers has to be a prime number. Now, if it is a prime number, then we will again calculate sum again, and we will check whether the sum of digits is a perfect square or not. That's the third condition we have. Now, in order to achieve this, you people will have to create 4 functions today, right? What those 4 functions are going to be? First is function is 4-digit. It will be a parametric function which will take one input, that is, we will provide a number, and this function is going to tell me whether the number given is 4-digit or not. Then we will create another function called sum of digits, right? Because it says sum of the 4-digit number. So you will have to sum the number, sum the digits of the number in order to know, right? So first, you will create a function called sum of the digit, which will simply calculate the sum of the number provided to it. Third function you will create is prime. Input given to this function will be sum of the number, right? That we calculated in the above function. Is prime will check whether the number fed inside is a prime number or not. Then, if it's a prime number, we will again calculate sum of digits, and now that new sum will be given to the fourth function is perfect square to know if the number is a perfect square or not. If all these conditions meets, we will call the number as miraculous, or otherwise we will be calling it as non-miraculous. So 6-step strategy, effective, we have to apply it. First step, problem understanding. Do we understand what needs to be done in this problem statement? Do we all understand what do we need to do? We have to check if a number is miraculous or not. We have certain conditions to check. Second step says, if you understood the problem, make some test cases. Let's have a look here, guys. 1, 2, 3, 7. Let's take this input. Now we have to check if it's a miraculous number or not, right? So first condition is it has to be a 4-digit number. We all can see it's a 4-digit number. So first condition meet. Now, because first condition met, we will go to the next part. Sum of 4-digit number. What's the sum of these 4-digit number? 7 plus 3, 10, 10 plus 2, 12, 12 plus 1, 13. 13 is a prime number. Second condition met. Now, since 13 is a prime number, again sum the digits. 13, 1 plus 3 makes 4. 4, we will check. Sum of digits should be perfect square. Is 4 a perfect square? Yes, 4 is a perfect square. So we will say input is a miraculous number. Let's take another case where the input given is 567. The first condition says has to be a 4-digit number. Since it's not a 4-digit number, we will directly say the number is non-miraculous. Do we all understand second step, how we have to go through the input and expected outputs? Okay, in that case, third step says we have to derive the solution, right? Guys, I want you people to pay attention over here. We have provided you the function signatures. Signature means that you will be having this function, parameter will be given input number, output has to be a Boolean. That means what your function has to do, it has to check if the number is a 4-digit number and return true if it's 4-digit longs, otherwise false. So we have mentioned you what each function has to return. Sum of digits will be returning a number. Is prime will be returning a Boolean value. Is perfect square will be returning a Boolean value. So signatures are mentioned here. Now coming to the part, ma'am, derive the solution. Solution is something you people will do, but we have provided you plenty hints over here that can make your job super easy. Now think about it. The first function we need to create is 4-digit. How do we know if a number is 4-digit or not? If it falls within the range of 1000 to 9999. So now you have a big hint here. How can we check if a number lies between this range? If it is lying between this range, we will return true. Otherwise, we'll return a false. First function is done. Then we have provided you the second function, that is sum of digits. Now you people will say, ma'am, you told us how to sum array elements, but you haven't taught us sum of digits, right? So we have given you step-by-step approach to do that as well. Let me quickly explain that over here. Let's say if the number given to us is 1, 2, 3, 7. We need to get the sum of digits. So let's make a variable sum. Now, what we will have to do, we'll have to get the individual digits from this. So what can we do in order to get the individual digits out of this particular entire number is that we can now say whatever the number we have, let's say n, right? Just get the mod of n, mod. Now, what would it return, guys? What would it return? Pay attention. 2, 3, 7 mod 10. Mod returns me remainder. So this is going to give me 7. And isn't 7 the last digit we have? Isn't 7 the last digit we have? Yes. So in that case, what we will do is that every time we will get the last digit and we will add it to our sum variable. So earlier sum was 0. Now sum has a value 7 inside, right? Now, but because I got the last digit, so from the number I have to remove it. Now, in order to remove it, we will divide n by 10. Guys, what I would get if I'm going to divide 1, 2, 3, 7 by 10? It would be returning me 123.7. But ma'am, we don't want to deal with this part. So that means you can simply do math.floor. And what it would take now? It would take 123. So these two steps needs to be A and B. These two steps needs to be repeated till the time number is greater than 0, right? So in order to sum all the digits, what are we doing here? We are using modulus in order to get the last digit, and then we are adding it to the sum variable, and then we have to remove it from the original number. So we will divide that up. Now we have written that step-by-step approach for you inside the hint already. Initialize the sum variable, extract the last digit using modulo 10, add that digit to the sum, remove the last digit from the number, repeat until the number is 0 and return the sum. So second function will simply return us a number output, which will be the sum. Now, the third function we will create is prime. Now, this is something we have to remember. Prime numbers can have a maximum of 2 factors, right? One and the number itself. Now, there can exist multiple approaches to check if a number is prime or not. We have mentioned one such here, but it's not rigid that you have to follow this one. If you have some better idea in mind, you can go and work with that too. We have provided a possible hint here that you can check the divisibility of the number from 2 to its square root. Similarly, the fourth function we have is perfect square. How do we know if a number is a perfect square or not now, guys? If you remember the math fundamentals, right? We just take the square root of the number, and if the outcome comes to be an integer, we call it as your perfect square number. Just for quick example, we can see, let's say if I have a number 4. In order to check if it's a perfect square or not, I'll be taking a square root of it. Ma'am, that returns me 2. 2 is an integer value. So I'll say this is a perfect square. Let's say I have 18, ma'am. Take the under root of 18. It would bring something 4.24. Is it an integer? No. So we will say 18 is not a perfect square. So there are 2 steps for you people to know if a number is perfect square or not. And that is, you will simply calculate the square root and then validate if it is an integer or not. 2 simple steps. So the entire project is not going to be beyond 15 to 20 lines of code. It's not difficult. Step by step, apply the 6-step strategy. All the relevant hints are provided to you people over here. That's your step number 3, guys. Now, please let me know if anyone is having any confusion, or I'll move to the last phase and explain this out. Anyone having any confusion till this point? Cool then. Now let me show you the interface. It's the same cryo platform, but I want you again to hear me very well here. Right? Please hear me out over here. What we have mentioned, actually I'm doing that again right from the platform now. The entire problem description is mentioned here. Now, in order to not make any syntax error, right? Not make any syntax error by putting wrong spellings or no. What you people have to do, you have to create 4 functions. Guys, just copy paste them here, right? Just select the name as it is along with the parameter and just start having them over here. These are the 4 functions you people are going to create. That is, you will check if the number is 4-digit. Then you will find sum of its digit. Then you will have the third function created, which is simply for the prime to check if the number is prime or not. And fourth function you will create is perfect square. Please make sure that none of us are falling into the trap that, ma'am, some syntax error is coming. Make sure the name of the function, spelling, parameters, everything you have taken up right from this portion. Now, why I am saying that is because you people just need to define the functions here. Calling part, we have already done, right? We have already written the function calling part. You people don't have to do it. Hear me out how we have written that part here. We are getting a number plate. Now we are checking first. We are checking with an if condition that if, and we will call your function of 4-digit to check if the number plate is a 4-digit number or not. Now, your function will be returning a Boolean value, right? If that Boolean value is true, if becomes true, only then we will come inside and call the sum of digits function. Only then the sum of 4 digits will be calculated. Now, after calculating sum, we will then give that sum to check if it's a prime number. If it is a prime number, we are again calling sum of digits to count the sum. And this new sum we are giving to check if it is perfect square or not. So you people don't have to call the functions. That part is something we have already taken care of. All you people have to do is define the logics into each of these 4 functions. Again, coming to the logical part, we have given you the hint how you can check if a number is 4-digit number or not. How can we find the sum of digits? We just have to Repeat those two steps. Two steps, extract the last digit and remove that last digit from the number there. To check if a number is prime number or not, we have multiple approaches. We have given you one possible hint here. You can verify the divisibility of number from 2 to its square root. Again, if you want to check if a number is perfect square or not, we have two steps. Calculate its square root and validate if the outcome is an integer or not. Multiple approaches exist, guys, in order to create these four functions. So you are free to use whatever comes into your mind. Ma'am, what was about step? That was for the first function, Manish, to know if a number is in 4-digit or not, right? All the 4-digit number lies into this range. So you will have to use that range in order to know if the number given lies into this range or not. Please follow the 6-step strategy, and I can assure you, you people can solve this project within 15 to 20 minutes as well. You also hint uses 1, 2, 3, 7. I explained that for the test case part. Yes, that 1, 2, 3, 4, 7 is basically lying between this range. So it's a 4-digit number. Since it's a 4-digit number, we will have to calculate the sum. These two steps we will repeat till the time number is greater than 0. Every time we are getting the last digit and we have to remove that last digit from the number then. So number will be updated as well. Once you are done, now you will have the sum. You will then go for your prime function. You will give that sum into prime to know if sum is prime or not. Now 1, 2, 3, 7, sum comes out to be 13, right? If you sum them up, sum comes out to be 13. So your prime function will say true. It's a prime number. Now, because it's a prime number, we will again calculate sum of its digits. So what would happen now? 1 plus 3 returns me 4. And this 4, we will check if it's a perfect square or not. In order to know if a number is perfect square, we just take the square root. After the square root, if the output we receive is an integer value, we call the number as a perfect square. If we are not getting an integer value, then it's a not perfect square number over there. Now, how we have to do this? You people are already having familiarity with Cryo platform. It's exactly the same thing. You will run, once after doing this part, you have to run your code. It will be run for one sample case. Then you will go for assessment. Now, in case if any of your assessment test case is failing, as I said, I'm not going to provide you people any help. Immediately, whichever test case is failing, pick that up and start to dry run your code, right? I am not entitled to provide you people any sort of help till the time all of the submissions are, all of your assessments are submitted, right? We will debrief this project, but once all of you have submitted this project over here. Does that make sense to everyone? Then I'll share the project link, and once I do, I'll start the timer, and I'm not going to provide any sort of help then. Cool, guys. In that case, again, I'm telling you, it's not at all hard. Hardly 15 to 20 lines of code you people have to write. All the best, everyone. Just be calm and solve it up. It's 50, guys. So right after 45 minutes, I'm gonna put the timer off, right? It's 8:50. All of you can start solving this up. By 9:35, all of us needs to complete this.